In the spring of 1942, at Fort Knox, Kentucky, two engineers positioned themselves 8 miles apart from each other. Each man held a prototype radio that was destined to transform battlefield communications in ways no one could fully imagine. Daniel Noble served as the director of research at Galvin Manufacturing Corporation. He pressed down on the transmit button of his prototype device and began speaking into the handset. His voice came through crystal clear, completely free from any static interference, traveling through the air by means of frequency modulation technology. 8 miles away from him, his colleague Henry Magnuski listened and heard every single word with perfect clarity. The Army's requirements had specified a minimum operational range of just 3 miles. Noble's team had just shown in their prototype testing that they could achieve more than double that specified distance. What made this particular achievement even more remarkable was the fact that the Army had originally mandated amplitude modulation AM technology for all portable radio equipment. Noble had managed to convince them to take a gamble on frequency modulation FM technology instead. He had argued forcefully that AM was fundamentally unsuited for the demands of battlefield communications. That gamble was now about to pay off in ways that would ultimately help win World War II. The SCR-300 walkie-talkie they were testing in the field would provide reliable communications over 3 miles in operational use, with up to 5 miles possible when conditions were optimal. This represented a threefold improvement over the existing handheld infantry radios currently in use, and it would give American troops such an overwhelming communication advantage that one general would later declare it the single most useful piece of communications equipment employed in the European theater of operations. This is the story of how one engineer's absolute insistence on superior radio technology revolutionized the way armies communicated on the battlefield and contributed materially to the Allied victory over the Axis powers. The journey to that breakthrough moment in Kentucky had begun back in September 1940. That was when Daniel Earl Noble walked through the doors of Galvin Manufacturing Corporation in Chicago to take up his position as director of research. He had been born on October 4th, 1901 in Norridge, Connecticut. Noble had earned his engineering degree from the University of Connecticut and had made his name in radio circles by designing the nation's first statewide two-way FM radio communication system for the Connecticut State Police, which was completed in 1940. He understood exactly what FM technology could accomplish. It offered noise rejection, clarity, and reliability in the presence of electrical interference that completely crippled AM systems under the same conditions. Noble arrived at Galvin Manufacturing at a pivotal moment in the history of America and the world. War had already engulfed the entire continent of Europe. France had fallen to Nazi Germany back in June 1940. Britain now stood completely alone against the Third Reich, enduring the terrible Blitz while the Royal Air Force fought desperately in the Battle of Britain. Though America remained officially neutral at this point, military involvement seemed absolutely inevitable to anyone who was paying close attention to world events. President Roosevelt had already begun the military buildup that would accelerate dramatically over the coming year. The Army was scrambling frantically to modernize its equipment, its doctrine, and its training for a war that would be fought on a scale that no one had fully imagined or prepared for. Among the many deficiencies that the military faced as it prepared for possible war, battlefield communications ranked among the most critical areas of concern. Modern warfare required coordination across unprecedented distances and among unprecedented numbers of individual units operating simultaneously. Infantry squads needed reliable ways to communicate directly with company and battalion headquarters. Forward observers needed the ability to call in artillery fire with both precision and speed. Tank commanders needed to coordinate effectively with infantry support units. Commanders at every level of the military hierarchy needed to maintain situational awareness of the battlefield and issue orders rapidly as tactical situations evolved and changed minute by minute. But the radios that were available in 1940 were woefully inadequate for meeting these demanding requirements. The Army had experimented with portable infantry radios during the late 1930s. The SCR 194 and SCR 195 had been attempts to give infantrymen truly portable communications capability, but these early efforts had been dismal failures in every respect. They used primitive superregenerative circuits that were temperamental at best and completely unreliable at worst under field conditions. They operated on AM frequencies, which meant that every electrical motor, every vehicle engine, every thunderstorm, and every piece of electrical equipment generated static and interference that drowned out vital communications when they were needed most. The radios were so unreliable in actual field use that infantry officers had grown deeply cynical about radio communications in general as a useful tool. Many officers preferred to rely on runners carrying messages by hand, even though runners could be killed or wounded in action, and even though messages might arrive far too late to affect the tactical situation they addressed. At least runners were reliable in a way that radios simply were not. Galvin Manufacturing had already achieved some success in the field of military communications with their handheld radio, the SCR 536, which had been nicknamed the handy-talkie by soldiers. Don Mitchell, who served as Galvin's chief engineer, had driven that development program forward, and the Army had been impressed enough with the results to award the company a significant production contract. President Franklin Roosevelt's Secret Service was reportedly using the handy-talkie to protect the president even before Pearl Harbor brought America fully into the war. The SCR 536 represented genuine innovation for its time period. It was compact and truly handheld, with the microphone, earphone, batteries, and antenna all integrated into a single 5-pound case that a soldier could operate effectively with just one hand. It operated on high-frequency AM from 3,500 to 6,000 kilocycles and was crystal-controlled for frequency stability, which represented an improvement over earlier radio designs. But the SCR 536 had one crippling limitation that no amount of engineering refinement could possibly overcome within its basic design parameters and physical constraints. Its maximum effective range was approximately 1 mile under good conditions at best. That limited range might work adequately for communications within a platoon, between squad leaders and their platoon sergeant, or between a company commander and his platoon leaders if they stayed relatively close together during operations. But it was completely useless for anything beyond that very limited range. Infantry companies couldn't talk to battalion headquarters located several miles to the rear. Forward observers couldn't direct artillery fire from observation posts that were miles away from the batteries they were supporting. Tank platoons couldn't coordinate effectively with infantry companies during combined arms operations across any significant distance. The 1-mile range of the SCR 536 made it a useful tool for tactical communications at the very lowest level of military organization, but it left a gaping hole in the military's ability to command and control forces across the distances that modern mobile warfare absolutely required. Shortly after Noble joined Galvin Manufacturing in September 1940, he accompanied Don Mitchell on a trip to Fort Monmouth, New Jersey, to present the handy-talkie to the Army Signal Corps for their official evaluation. Among the Signal Corps officers who were present that day were 2 men who would play crucial roles in the development of longer-range portable radio communications for the military. Colonel Roger B. Colton had been serving as director of Signal Corps Laboratories since 1938. Major James Dunn O'Connell served as executive officer of the laboratories and would soon be heading up radio communications projects. The Signal Corps officers were genuinely pleased with the handy-talkie's performance and design characteristics, but they made it very clear to Noble and Mitchell that they needed something more, something significantly different. They needed a radio with substantially greater range that could still be carried and operated by an infantryman during combat operations. The Army needed a portable radio that could bridge the communication gap between company and battalion levels. It needed to reach back 5 or even 10 miles to higher headquarters when necessary. It needed to function effectively in the electromagnetically noisy environment of modern mechanized warfare with all its running engines and electrical equipment. In 1940, facing this specific requirement from the military, the Signal Corps contracted for development of a new portable AM transmitter receiver. The decision to specify AM technology was completely understandable given the military's experience and existing infrastructure. AM was established, proven technology that had been around for decades. The military knew AM inside and out, trusted AM based on years of experience, and had built its entire communications infrastructure around AM technology and frequencies. Military radio operators were trained exclusively on AM equipment. Maintenance personnel knew exactly how to repair AM radios in the field. The entire logistics system was designed specifically to support AM equipment with the right spare parts and supplies. AM was the safe, conservative choice for a military organization that valued reliability and maintainability above almost everything else. When Noble learned of this decision during meetings in Washington, his response was immediate, forceful, and extraordinarily risky for his career. He told Major O'Connell directly that contracting for an AM portable radio was a grave mistake that would waste resources and fail to meet battlefield needs. The area of development, Noble insisted with absolute conviction, should be for an FM portable unit instead. This was an extraordinarily bold stance to take with military procurement officials who had already made their decision. Noble was essentially telling the Signal Corps that they were making a fundamental error in their technical approach to the problem. He was contradicting the military establishment's preferred technology and decades of institutional experience. He was advocating for a more complex and potentially more expensive solution when a simpler option seemed available. He was asking the Signal Corps to take a chance on a technology that many radio engineers still considered impractical for portable military applications in the field. AM was familiar and comfortable to everyone involved. FM was exotic, newer, and less proven in military applications under demanding field conditions. FM required wider bandwidth than AM, which meant that fewer channels could fit in any given frequency allocation. In an era when radio spectrum was already considered a scarce and precious resource that had to be carefully managed, that bandwidth requirement seemed like a serious drawback that might outweigh any potential advantages FM could offer. FM circuitry was more complex than equivalent AM circuitry, which raised legitimate concerns about reliability in harsh field conditions and the ability of military maintenance personnel to keep the equipment operational when it broke down. FM transmitters and receivers required more sophisticated components and more precise tuning mechanisms than their AM counterparts, which added cost and complexity. But Noble understood something critically important that many radio engineers of that era did not fully appreciate or recognize. He understood that FM offered genuine fundamental advantages that would more than outweigh its complexity and cost in actual battlefield applications. FM inherently rejected electrical interference and noise in ways that AM simply could not, due to the fundamental physics of how the two technologies worked. FM provided clear voice transmission even at the very limits of its operational range, while AM signals faded progressively into worse and worse static and noise as range increased. FM would work effectively in the electromagnetically hostile environment of a modern battlefield, near running vehicle engines and electrical equipment, in conditions that would render AM radios nearly useless for practical communication. Noble had seen this demonstrated convincingly in his Connecticut State Police FM system, where FM radios maintained crystal-clear communications in conditions where AM radios would have failed completely. Noble's absolute conviction about FM superiority, combined with his proven track record of successful engineering work and his deep technical expertise, ultimately carried the day with the military decision-makers. Major O'Connell, convinced by Noble's passionate and technically grounded arguments, issued a Signal Corps contract for development of an FM portable transmitter receiver to Galvin Manufacturing Corporation. The designation assigned to this new radio development program would be SCR 300, meaning Signal Corps Radio Number 300. With that contract officially in hand, Noble and his team embarked on one of the most challenging and ultimately most successful engineering projects of the entire World War II period. Back in Chicago at the company's facilities, Noble moved quickly to assemble his engineering team for this critical project. The core group would consist of some of the brightest minds that Galvin Manufacturing could field. Henry Magnuski, who had immigrated from Poland and would become one of the company's most distinguished engineers over his career, would serve as principal RF engineer. He was the man responsible for designing the critical radio frequency circuits that would literally make or break the entire project. Marion Bond, Lloyd Morris, and Bill Vogel rounded out the core team, each bringing specialized expertise in different aspects of radio design and development that would be crucial. They would need every ounce of that combined expertise and experience because the Army specifications for the SCR-300 were extraordinarily demanding in every respect. The SCR-300 had to be battery-powered with sufficient energy capacity to operate for useful periods in the field without requiring frequent battery changes that would be impractical during combat operations. It had to weigh no more than 35 pounds complete with batteries and all necessary accessories. Light enough for an infantryman to carry on his back for extended periods while still being able to fight effectively when necessary. It had to provide reliable communications over a distance of at least 3 miles in varying terrain conditions, through forests and over hills, in conditions far more challenging than simple line-of-sight transmission in open country. It had to be water-resistant enough to withstand rain and the general moisture and humidity of field conditions without failing or degrading in performance. It had to be simple enough for soldiers with minimal technical training to operate effectively under the extreme stress and confusion of actual combat situations. It had to tune across a range of frequencies from 40 to 48 megahertz, providing multiple channels so that different units could operate simultaneously without interfering with each other's communications. And critically, given the realities of wartime production constraints, it had to use only 2 frequency control crystals because crystal production was already a bottleneck that would become increasingly critical as war production ramped up across all types of radio equipment throughout the military. Meeting all these specifications simultaneously seemed almost impossible to the engineers who first reviewed them. Each individual requirement by itself was challenging enough. Taken together, they represented an engineering puzzle of extraordinary difficulty that would test the limits of their knowledge and creativity. But Noble's team had one enormous advantage that made the seemingly impossible merely very difficult to achieve. They were using FM technology, and FM's inherent characteristics would help them solve several of the most challenging problems they faced. One morning in late 1940, soon after Noble had formed his team and received the official contract from the Signal Corps, he approached Henry Magnuski and Andy Affronti. Affronti was a young engineer who had just started working in the research laboratory. Noble asked them both to sit at Affronti's workbench, motioning Magnuski to sit at his right and Affronti at his left. He placed an official-looking sheet of paper on the bench between the two men. Affronti noticed the formal heading that read United States Army Signal Corps across the top. Noble read the 8 paragraphed items aloud carefully, explaining each specification in detail for what would become the SCR-300 radio. He finished by saying something that burned itself permanently into the memories of both engineers, words they would remember clearly for the rest of their lives. Henry and Andy, I want you to start working on this immediately. During my visit to the Signal Corps last week, they placed a life and death priority on this program for the infantry. You'll get whatever assistance you need from anyone in the company, and I expect to see a working prototype fabricated as soon as possible. Shocked by the urgency and the enormous weight of responsibility he had just placed squarely on their shoulders, Magnuski and Affronti read and reread that single sheet of paper several times, absorbing every detail and implication. The Signal Corps designated this communications equipment as a portable infantry battalion transceiver with the nomenclature SCR-300. This was a specification document to design and develop a portable frequency-modulated radio receiver and transmitter that would be powered entirely by batteries. The complete equipment should not weigh over 35 pounds and must be designed to be carried on the back of an infantry combat soldier during operations. It should provide solid, reliable communications over a distance of 3 miles minimum and must be waterproofed adequately against rain and field moisture. No more than 2 crystals could be used in the frequency control system, and it should cover a frequency range that was continuously variable from 40.0 to 48.0 MHz. The scope of the challenge was extraordinary in its difficulty, but so was the opportunity if they succeeded. If they succeeded in meeting all these requirements, they would give American soldiers a communications capability that no army anywhere in the world had ever possessed before. Working furiously against time and driven by the knowledge that soldiers' lives would literally depend on their success or failure, Noble's brilliant team developed a design that was revolutionary in multiple ways that went far beyond simple technical improvements. They created a single tuning control that would tune both the transmitter and the receiver simultaneously, completely eliminating the need for soldiers to adjust separate controls for transmission and reception. This seemingly simple feature was actually quite sophisticated technically, but it made the radio dramatically easier to operate under the stress of combat. They incorporated automatic frequency control circuitry that would lock onto the correct frequency and maintain it without drift, ensuring clear communication without requiring precision tuning on the part of the operator under difficult conditions. This was absolutely crucial because combat soldiers couldn't be expected to have the extensive training or the time or the steady hands needed to fine-tune radio circuits while under enemy fire or while moving rapidly through difficult terrain. They solved the challenging power supply problem by designing circuits that could operate efficiently on battery power while still delivering adequate transmitter output power and receiver sensitivity for effective communications. Battery technology in 1940 was extremely primitive by modern standards, and getting enough power for reliable radio operation without making the batteries so heavy that the entire radio exceeded its weight specification required extremely careful circuit design and component selection. They addressed the fungus proofing requirement by treating components with special coatings so the radio could withstand the tropical temperatures and extreme humidity of the Pacific theater, where much of the war would eventually be fought against Japanese forces. And they managed to do all of this while keeping the total weight at or below the 35-pound specification, though the final production version would end up slightly heavier when equipped with a full battery pack. The SCR 300 design that emerged from their intensive development effort was an 18-tube battery-operated VHF battlefield radio using FM transmission exclusively. The transmitter section and the double superheterodyne receiver were both designed completely around FM technology, taking full advantage of FM's inherent noise rejection characteristics and its ability to provide clear audio even at the very limits of operational range. The radio incorporated an adjustable squelch circuit, a feature that was completely new to military radios at that time and would prove to be a tremendous operational advantage in actual use. With AM radios, operators had to listen to constant hissing, crackling noise whenever no one was actively transmitting. This constant noise was mentally fatiguing over long periods and made it easy to miss the beginning of an incoming transmission. The squelch circuit silenced the receiver completely when no signal was present, saving operators from mental fatigue and making it immediately obvious when an actual transmission came through. The sudden break of silence commanded attention instantly in a way that a slight change in noise level never could under combat conditions. The automatic frequency control circuit ensured frequency stability across all available channels without requiring constant operator adjustment throughout the day. The crystal control calibration circuit allowed operators to verify their frequency setting easily, ensuring that units that were supposed to be on the same channel were actually tuned to exactly the same frequency. The tuning mechanism was elegantly simple from the operator's perspective, with a single control knob and a channel display showing channels 0 through 40, providing 41 channels total across the 40 to 48 MHz range with 200 kHz spacing between adjacent channels. 2 frequency control crystals operating on harmonics provided calibration reference points that allowed the variable tuning mechanism to cover all 41 channels accurately. This was an elegant engineering solution to the 2 crystal limitation, using harmonic relationships and careful frequency synthesis to generate all the frequencies needed from just 2 crystal references. The entire radio could be set up for relay or retransmission operation, allowing 2 SCR, 300 units to extend communications range far beyond normal line-of-sight limitations. One radio would receive a transmission and automatically retransmit it without any operator intervention, effectively doubling or tripling the communication range without requiring the operators to do anything more complicated than set a switch to the correct position. This relay capability would prove invaluable in mountainous terrain or in situations where headquarters needed to maintain contact with forward units that were beyond direct radio range. By spring 1942, Magnusky, Affronti, and the rest of the engineering team had 2 working prototypes ready for field testing. The prototypes represented more than a full year of intensive engineering work, countless late nights at the laboratory, numerous dead ends and false starts that had to be abandoned, and the kind of intensely focused problem-solving that characterized American engineering at its absolute best during the war years. On a bright spring day at Fort Knox in Kentucky, the moment finally came that would prove whether Noble's advocacy for FM technology and his team's year of intense development work had been justified. Magnusky and Affronti stood 8 miles apart, far more than the 3-mile operational range specification the Army had demanded in its original requirements. Magnusky, standing on the flat roof of the Tropic Air Building with his prototype radio, keyed the transmit button and spoke clearly into the handset. 8 miles away, far beyond the specified minimum range, Affronti heard the transmission with perfect clarity that surprised even him. They tested and retested repeatedly, varying frequencies, checking different channels, trying the radios in different locations and orientations to simulate various field conditions. The prototypes performed flawlessly every single time, demonstrating range that far exceeded the Army's requirements. When Signal Corps representatives arrived just days later for their formal evaluation of the prototypes, they witnessed demonstrations that impressed them enough to give immediate approval to proceed with production development. Further development work and refinement led to the production version of the radio, which was designated BC 1000. This radio unit, combined with all required accessories including the battery pack, carrying harness, antenna, and handset, comprised the complete SCR 300 walkie-talkie system. The final weight came in at approximately 38 pounds with a larger BA 70 battery or 32 pounds with the smaller BA 80 battery. This was slightly over the original 35-pound specification, but the Army readily accepted the additional weight as a reasonable trade-off for the radio's exceptional performance and reliability in testing. For the Army's final acceptance test before authorizing full-scale production, the production SCR 300 traveled to Fort Knox, Kentucky, home of the Armored Force School. There, in the woods and fields and rolling hills surrounding the base, the radio unit underwent comprehensive and rigorous trials designed to verify every aspect of its performance characteristics, its ruggedness under field conditions, and its usability by soldiers with typical training levels. The Infantry Board, an organization known throughout the entire Army for being highly critical of communications equipment and deeply skeptical of manufacturers' claims, had been invited as observers. The Infantry Board had rejected numerous pieces of equipment over the years based on their rigorous testing, and their approval carried significant weight throughout the military. Bob Galvin, son of company founder Paul Galvin, accompanied Dan Noble and Bill Vogel to Fort Knox for these critical tests. The stakes were extraordinarily high for everyone involved. They had only 2 working production models available, and if anything went wrong during the testing, if the radios failed to perform as promised, the entire program could be seriously jeopardized or even canceled entirely. Each night during the testing period, the team returned to their hotel and carefully checked over both radios, inspecting every component and connection meticulously, ensuring they would be ready for the next day's tests. The performance of the SCR 300 during those Fort Knox trials exceeded everyone's expectations, even Noble's high hopes. The radio communicated clearly through interfering ignition noise from running vehicles, proving in practical field conditions that FM's theoretical resistance to electrical interference translated into real operational advantages on the battlefield. The radio continued to function properly after being subjected to rough handling, drops, exposure to rain, and the kinds of abuse that military equipment inevitably receives in actual field use. The rugged quality of the mechanical and electrical design was evident in how well the radios held up under conditions that would have destroyed more delicate equipment quickly. The infantry board officers, who had seen countless pieces of communications equipment fail to live up to manufacturers' promises and marketing claims over many years, responded with unusual and uncharacteristic enthusiasm. This radio actually worked exactly as advertised under real conditions. It worked in conditions that would have rendered AM radios nearly useless for practical communication. It was robust enough for field service under harsh conditions. It was simple enough for ordinary soldiers to operate effectively without extensive technical training. The infantry board gave their official approval, which carried more weight than any amount of laboratory testing could have provided. The Signal Corps immediately placed orders for production. Galvin Manufacturing Corporation, which would officially change its corporate name to Motorola in 1947, would go on to produce nearly 50,000 SCR 300 units during the course of the war. The first production units coming off the assembly line were rushed by air transport for immediate use by Allied forces in active combat theaters. The military placed such extraordinary urgency on fielding the SCR 300 because communications problems in the North African and Sicilian campaigns had been severe and had directly impacted combat operations with serious consequences. Message delivery had failed at critical moments, leaving commanders operating blindly without knowledge of the battlefield situation. Units couldn't coordinate attacks effectively because they couldn't communicate reliably. Artillery support couldn't be adjusted in real time because forward observers couldn't maintain reliable communications with their firing batteries when it mattered most. These communications failures had cost lives unnecessarily and degraded combat effectiveness significantly. In August 1943, the volcanic island of New Georgia in the Solomon Islands became the scene of bitter fighting as American forces pushed forward relentlessly in their island-hopping campaign across the Pacific toward Japan. The SCR 300 made its combat debut here in the Pacific Theater, arriving in time to support operations in some of the most challenging communications terrain imaginable. Colonel Ankenbrand, the theater signal officer responsible for communications throughout the entire Pacific region, evaluated the new radios under actual jungle combat conditions. Initially, he had been deeply skeptical about the SCR 300's suitability for Pacific operations in dense jungle. Earlier in 1943, when he was informed that the SCR 511 radio was being replaced by the SCR 300, Ankenbrand had actually protested the decision strongly to his superiors. He believed firmly that VHF radios like the SCR 300 would not work well in dense jungle operations. His skepticism was based on sound technical reasoning and experience. The tropical environment was absolutely brutal on electronic equipment of all types. The thick vegetation of jungle terrain absorbed and scattered radio waves significantly. The mountainous terrain of most Pacific islands created radio shadows and dead zones that blocked communications. All of these factors seemed to argue strongly against VHF operation and in favor of lower frequency radios with longer wavelengths that could propagate more effectively through obstacles. But when the SCR 300 arrived in quantity and troops began using it extensively in actual combat operations, Ankenbrand changed his assessment completely based on the field results. The FM radio's performance in jungle conditions surprised everyone involved, including the skeptical signal officer who had opposed its introduction. By January 1944, after several months of combat use in various operations, Ankenbrand was writing enthusiastic reports to General Meade stating clearly, the SCR 300 sets have now been in action in the Tokina area, Bougainville, in the hands of the 37th and Americall divisions. and I have a preliminary report on them indicating that they are exactly what is needed for frontline communications in this theater. The phrase, exactly what is needed, coming from a skeptical signal officer who had initially opposed the radio's introduction, represented powerful vindication of Noble's technical choices and his team's engineering work. Ankenbrand noted in his reports that the chief difficulty from an operational perspective was keeping the radios supplied with fresh batteries. The BA-70 and BA-80 batteries that powered the SCR-300 had limited operational life under the high-temperature, high-humidity conditions of the Pacific Theater. And in the high-tempo operations of jungle warfare, batteries drained more quickly than they did in temperate climates. But that was fundamentally a logistics and supply problem, not a fundamental flaw in the radio design itself. The communications capability the SCR-300 provided was exactly what frontline commanders needed to control their units effectively in the confused, close-quarters fighting of jungle warfare. Second Lieutenant Joseph Doley, communications officer of the 298th Infantry Regiment, provided detailed operational feedback from the soldiers who actually carried the radios in combat and used them under enemy fire. The main complaint that came up repeatedly in after-action reports concerned the harness design. The weight distribution of the standard harness placed too much of the load too low on the operator's back, which caused significant fatigue during long marches through difficult jungle terrain. The belt carrier brackets had a tendency to jab the operator painfully in the kidneys during movement, which was painful and added significantly to fatigue over time. These were legitimate comfort and ergonomics issues that could be and eventually were addressed with improved harness designs, but they didn't diminish the tactical value of the radio itself at all. Despite these minor complaints about the carrying system, Doley concluded his formal report by calling the SCR-300 an infantryman's dream for better communication and control of troops by radio than ever before given us. That phrase, an infantryman's dream, coming from a junior officer who had led infantry soldiers in jungle combat and who understood their needs and challenges intimately, represented exactly the kind of endorsement that Noble and his team had hoped to earn. The radio worked effectively in the field. It worked under direct enemy fire. It gave infantry commanders a capability they had never had before in any previous conflict. The tropical environment of the Pacific created unique challenges for all electronic equipment, not just radios specifically. Earlier versions of the SCR-536 handy-talkie had failed catastrophically and rapidly in jungle conditions, with some units lasting only 36 hours before corrosion, humidity, and fungus growth rendered them completely inoperative and useless. These failures have been so severe and so rapid that they threatened to leave entire units without any radio communications capability at all during operations. The Signal Corps had responded by developing specialized tropicalization treatments, including special fungus-inhibiting shellac coatings that were carefully applied to components and then baked on at controlled temperatures to ensure proper adhesion and complete coverage. These treatments were applied systematically to all radios and electronic equipment being sent to the Pacific Theater of Operations. The tropicalized SCR-300 sets proved dramatically more resistant to the harsh tropical environment than earlier radio designs had been in the same conditions. Instead of failing within days, as earlier radios had, the tropicalized SCR-300 radios lasted through extended operations lasting weeks or even months, requiring only normal maintenance and regular battery replacement. This durability under extremely adverse environmental conditions demonstrated the fundamental soundness of the engineering design and the effectiveness of the tropicalization treatments that had been developed specifically to address Pacific Theater requirements. In September 1943, the invasion of the Italian mainland began with American and British forces storming ashore at Salerno and Calabria, opening up a new front in Europe and beginning the long, costly campaign up the Italian peninsula. The SCR-300 saw its first extensive use in the European theater during these operations. Radio operators waded through the surf with the 32 to 38-pound radios strapped firmly to their backs, hit the beach under intense German artillery and machine gun fire, and immediately began establishing communications networks even as the battle raged violently around them. In the first chaotic hours and days of the invasion, when units were scattered and disorganized across the beachhead, when commanders were desperately trying to establish control and coordinate actions effectively, the value of the SCR-300 became dramatically apparent to everyone. Company commanders could talk directly to battalion headquarters that might be several miles to the rear, either still on ships offshore or at temporary headquarters established just off the beach. As companies advanced inland against determined German resistance, they maintained reliable contact even when terrain features like hills and ridges blocked direct line of sight between positions. This was a revelation for commanders who were accustomed to losing communications completely as soon as units moved any significant distance or moved behind terrain features. Forward observers, some of the first soldiers to receive the SCR-300 in significant numbers, could now call for artillery fire with unprecedented reliability and speed. Artillery spotters would climb to observation posts, sometimes several miles from their firing batteries, and watch carefully for enemy positions, movements, and concentrations. When they spotted targets worth engaging, they could immediately radio precise coordinates back to the fire direction centers. The batteries would fire their missions based on these coordinates, and the observers would watch the shell's impact, then radio back precise corrections for subsequent salvos to bring fire directly on target. This observe-adjust-fire cycle, fundamental to effective artillery support, depended absolutely on reliable communications between the observer and the firing battery. Previously, this critical communications link had been frustratingly unreliable with AM radios under field conditions. Static and interference would cause observers to lose contact at crucial moments. Transmissions would be garbled and unintelligible, requiring multiple repetitions that wasted precious time. Observers would sometimes watch enemy forces moving into perfect target areas and be completely unable to call in fire, because their radios simply wouldn't work reliably at the required range or in the electromagnetic environment of active combat. The SCR-300 fundamentally changed this entire situation for the better. The FM signal cut through the electrical noise and interference that was inevitable on any battlefield. The clarity was such that map coordinates could be transmitted and confirmed without repetition or confusion. Fire missions that had once taken many minutes to coordinate because of communication difficulties could now be executed swiftly and accurately, often in a fraction of the time previously required. The practical usefulness of the SCR-300 and the dependability of its rugged design quickly became apparent to the soldiers using them in combat operations. The U.S. Army was still experiencing growing pains and learning hard lessons in 1943 when fighting against experienced German forces who had been at war since 1939 and knew their business. American units were learning how to fight a modern combined arms war against a skilled and determined enemy. And that learning process often came at painful cost in casualties and temporary setbacks on the battlefield. In this challenging environment, the instant communication afforded by the SCR-300 proved invaluable to frontline soldiers and their commanders at every level of the chain of command. When a unit came under unexpected attack and needed immediate reinforcement to avoid being overrun, the SCR-300 allowed company commanders to call for help and have reserve units moving to their assistance within minutes instead of the hours it might take for a runner to carry a message back to battalion headquarters through difficult terrain or under enemy fire. When German counterattacks threatened to overwhelm a defensive position, the SCR-300 allowed defenders to call in concentrated artillery barges that could break up the attack before it succeeded in penetrating the defensive line. The radio was quite literally worth its weight in gold to soldiers whose lives depended on being able to communicate reliably with supporting units and higher headquarters. As production of the SCR-300 continued through 1943 and into 1944, the radios were issued in increasing quantities to other units and other branches of service besides the Army infantry. The Marine Corps, Army airborne units, Army Air Force ground controllers, and Navy shore parties all received allocations of the SCR-300. The Marines were particularly enthusiastic about the radio's capabilities. In the Pacific Theater, where dense jungle terrain and mountainous topography made communications notoriously difficult, and where units could become isolated and cut off with terrifying speed, the SCR-300's ability to maintain reliable contact over several miles gave Marine commanders a level of tactical coordination and control capability they had never before possessed in jungle fighting. In June 1944, on the coast of Normandy, France, Operation Overlord began. This was the largest and most complex amphibious invasion in human history up to that point. Approximately 6,900 vessels of all types carried approximately 156,000 Allied soldiers toward the beaches of Normandy to begin the liberation of Western Europe from Nazi occupation. The armada stretched as far as the eye could see in every direction. Among the mountains of equipment loaded onto those landing craft, carefully packed and waterproofed against the salt spray and inevitable immersion, were thousands of SCR-300 radios. The lessons learned about the critical importance of reliable battlefield communications in Italy and the Pacific had been thoroughly absorbed by the invasion planners. They ensured that every unit that could benefit from the SCR-300's capabilities received adequate quantities of the radios for the operation. As the first waves of infantry hit Omaha Beach, Utah Beach, and the other landing sites in the pre-dawn hours of June 6, 1944, radio operators carrying SCR-300s waded ashore through the surf and across the beaches under withering German artillery, mortar, and machine gun fire, with soldiers dying and being wounded all around them. These radio operators had the critical mission to establish and maintain communications networks that were absolutely critical to the success of the entire invasion. The difference between the SCR-300 and earlier AM radios became immediately and dramatically apparent in the chaos and electromagnetic noise of the invasion beaches. The beaches were scenes of almost indescribable chaos and confusion. Hundreds of vehicles, landing craft with their engines running continuously, tanks, bulldozers, trucks, and other equipment created an electrical environment that generated massive amounts of radio interference. Any AM radio trying to operate in that environment would have been swamped completely by ignition noise and electrical interference from all the running engines and electrical equipment. The SCR-300's FM signal cut through all of that interference, as if it didn't exist, maintaining clear communications when clear communications meant the difference between success and catastrophic failure. Battalion commanders on the beaches could talk directly to regiment commanders who might be on ships offshore or at temporary command posts that had been established just inland from a beach. Artillery forward observers accompanying the assault waves could direct naval gunfire from the massive guns of battleships and cruisers against German strong points and defensive positions. And the communications remained clear and reliable enough to ensure accurate fire missions even in the midst of the intense battle. As units pushed inland from the beaches through the hedgerow country of Normandy, the SCR-300 maintained contact through terrain that would have made communications with AM radios extremely difficult or impossible. One technical feature of the SCR-300 that became critically important during the Normandy campaign was the relay or retransmission capability that had been built into the design from the beginning. Two SCR-300 units could be set up to automatically relay transmissions between them, effectively extending the communications range well beyond what any single radio could achieve and allowing communications across terrain features that would otherwise block radio signals. In the confused fighting through the bocage, the distinctive hedgerow country of Normandy, where fields were separated by thick earthen banks topped with dense vegetation that limited visibility to single fields and created perfect defensive positions, relay operations allowed regimental headquarters to maintain contact with forward battalions that might be several miles away behind multiple ridge lines and through numerous hedgerows. The technical sophistication of the automatic frequency control and crystal-controlled tuning meant that relay operations worked reliably without requiring constant manual adjustment or skilled operator intervention. The signals remained clear, the frequencies remained stable, and the communications flowed as designed, even when relay stations were being operated by soldiers under fire who had many other things to worry about besides fine-tuning their radios. Emergency requisitions dated June 21, 1944, just 15 days after D-Day, requested an additional 200 SCR, 300 units to replace combat losses from destroyed or damaged radios, and to expand distribution to additional units that had discovered they needed the enhanced communications capability the radio provided. This urgent requisition, so soon after the invasion, demonstrated the high demand for the SCR 300 and the recognition by commanders at all levels that this radio was not a nice-to-have luxury, but rather an essential combat multiplier that directly contributed to battlefield success. As Allied forces broke out from a Normandy beachhead in late July and early August 1944 and began the rapid advance across France that would carry them to the German border by September, the SCR 300 proved its value repeatedly in mobile operations where maintaining communications while on the move was essential. Tank infantry coordination, which was absolutely critical to the success of combined arms operations, required reliable communications between tank commanders and infantry company commanders. Armored spearheads, racing ahead, needed to stay in contact with following infantry units and with logistics elements bringing up fuel and ammunition. Flank guards, screening the advancing columns, needed to report enemy movements and potential threats. All of this depended on radios that worked while vehicles were moving, while engines were running, while commanders were trying to make rapid decisions based on fluid tactical situations. The SCR 300 delivered this critical capability consistently and reliably. In December 1944, the Ardennes forest in Belgium and Luxembourg became the scene of desperate fighting. The weather was utterly miserable. Sub-freezing temperatures, heavy snow, dense fog, and solid overcast skies grounded Allied aircraft and eliminated the air superiority that the Allies had enjoyed since Normandy. Through this weather, taking advantage of the conditions that grounded Allied air power, Adolf Hitler launched Operation Walk am Rhein, his last desperate gamble in the West. This was a massive surprise offensive that would become known to history as the Battle of the Bulge. The German attack achieved complete tactical and operational surprise. German armored and infantry forces smashed through thinly held American defensive lines, creating a dangerous bulge or salient in the Allied front that threatened to reach the Meuse River and potentially split the Allied armies. In the chaos and confusion of the German attack, with units scattered and intermixed, with defensive lines breaking and reforming, with some American units cut off and surrounded, communications became absolutely crucial in determining whether American forces would disintegrate into isolated groups fighting hopeless individual battles or would maintain enough coherence and coordination to organize an effective defense and eventual counterattack. This was where the SCR 300 proved its greatest value in the European theater. Units that were cut off or surrounded, units that had lost physical contact with adjacent units and with higher headquarters, could maintain radio contact with battalion and regimental headquarters using the SCR 300. This radio lifeline meant that surrounded units weren't fighting blindly and desperately in isolation. Commanders could coordinate movements, could organize withdrawals to more defensible positions, could establish new defensive lines, and could call for reinforcements and supplies because they could communicate reliably with higher headquarters despite being physically cut off by German penetrations. Artillery forward observers, who were among the most critical users of the SCR 300 throughout the war, could continue to call fire missions even when their observation posts were partially isolated by German advances. The ability to rapidly mass artillery fire on German armored spearheads and infantry formations was very often the critical factor that determined whether a defensive position would hold or would be overrun by the attacking Germans. The SCR 300 made it possible to concentrate artillery fire from multiple batteries on critical targets within minutes, creating walls of exploding shells that could stop or at least slow down German attacks. The battles around the town of Bastogne, where the 101st Airborne Division and attached units were completely surrounded by German forces for more than a week, depended absolutely on radio communications to coordinate supply drops from Air Force C-47 transport aircraft, to direct artillery fire from batteries both inside and outside the encirclement, and to maintain contact with the relief forces that were fighting their way through German lines to reach the besieged garrison. Without the reliable communications that the SCR-300 provided, the defense of Bastogne would have been vastly more difficult, if not impossible. When the Battle of the Bulge finally ended in late January 1945, with the German offensive decisively defeated and German forces pushed back to their starting positions with catastrophic losses they could not replace, American commanders and staff officers compiled extensive after-action reports analyzing what had worked and what hadn't during the desperate fighting. One assessment that appeared repeatedly in these reports and in subsequent historical analyses was that many officers felt the SCR-300 walkie-talkie was perhaps the single most useful piece of communications equipment employed in the battle. In the chaos and confusion of the Battle of the Bulge, where units were mixed together across normal organizational boundaries, where defensive lines shifted rapidly from hour to hour, where the fog of war was both literal because of the weather and figurative because of the confused tactical situation, the ability to maintain clear and reliable communications across distances of several miles had been absolutely critical to mounting an effective defense and organizing successful counterattacks. The SCR-300 had given American forces a communications capability and a resulting level of command and control that the attacking German forces could not match, and that communication superiority had contributed materially to the American victory. The SCR-300 had given American and Allied forces a communication superiority over their enemies that translated directly into battlefield advantages. German radio communication systems still relied predominantly on AM technology throughout the war. While German engineers had developed some FM equipment late in the war, it was never available in the quantities, never achieved the level of reliability, and never reached the sophisticated level of design that characterized American FM radio production. The Wehrmacht had backpack portable radios that were comparable in concept to the SCR-300, but they were generally larger and heavier than the American radio, less reliable under field conditions, and some models required external power sources or used rechargeable batteries that required access to charging equipment, which was a significant operational limitation in fluid combat situations where units might be cut off from rear area support for extended periods. Japanese forces in the Pacific Theater had backpack radios for infantry communications, but some Japanese radio designs relied on hand-crank generators that required one soldier to continuously and laboriously crank a generator handle, while another soldier operated the radio. This was an extremely cumbersome arrangement that effectively removed two soldiers from combat, tiring out the soldier doing the cranking and occupying the attention of the radio operator. The SCR-300, by contrast, was powered by self-contained batteries and could be operated by a single soldier who carried the radio on his back and still had both hands free to use his weapon if necessary. This represented a significant tactical and technical advantage that contributed to overall American and Allied superiority in battlefield communications and command and control. At Galvin Manufacturing Corporation, which officially adopted the name Motorola in 1947, production of the SCR-300 continued at high volume throughout the war years. The radio was also manufactured under license by several other companies beyond Motorola as production was expanded to meet growing demand, and eventually some production took place in France and Italy under license as those countries were liberated and their industrial capacity was brought into the Allied war effort. The production achievement represented a remarkable feat of wartime industrial mobilization and manufacturing expertise. Each SCR-300 contained 18 vacuum tubes of various types, dozens of resistors, capacitors, transformers, and other electronic components, all of which had to be manufactured to exacting military specifications. The radios required precision manufacturing and assembly to ensure that they would function reliably under the harsh conditions of combat use. Each completed radio had to be thoroughly tested before being accepted and shipped to ensure it met all performance specifications. The company and its licensees produced nearly 50,000 of these complex radios during the war, and each one had to work reliably in combat because soldiers' lives depended on it. The engineering team that had made this production possible, that had turned Daniel Noble's vision of an FM portable radio into a combat-proven reality, deserved recognition that extended far beyond the headlines and publicity that typically went to weapons systems and combat leaders. Daniel Noble received the Certificate of Merit from the United States Army for his role in the development of the walkie-talkie. This was a significant honor that recognized civilian contributions to the war effort. In accepting the award, Noble characteristically stressed the major contributions of Henry Magnuski, Bill Vogel, Lloyd Morris, and Marion Bond to the project's success. He went on to say something that revealed his character and his understanding of what military service and sacrifice truly meant. He stated that the development of the walkie-talkie was merely an academic exercise when compared to the contribution of the men on the battlefields, the men who were actually fighting the war. Those words, expressing genuine humility and recognition of the infinitely greater sacrifice made by combat soldiers, resonated deeply with the soldiers who carried the SCR-300 into battle. Those soldiers understood perfectly well that no piece of equipment, however innovative or well-designed, could substitute for the courage, sacrifice, and blood of the men who closed with and destroyed the enemy. But those same soldiers also understood with equal clarity that good equipment that worked reliably when you needed it, made their incredibly difficult and dangerous jobs somewhat easier, made their survival more likely, and made victory more certain and less costly. The impact and influence of the SCR-300 extended far beyond its immediate tactical applications in World War II. The radio represented a crucial proof of concept for FM technology in military applications that would influence and shape post-war communications development for many decades to come. Major General Roger B. Colton, who had been director of Signal Corps Laboratories in 1938 when the historic and controversial decision was made to employ FM in military radios, clearly recognized the long-term significance of that decision even while the war was still being fought. In a letter dated June 29, 1944, Edwin Howard Armstrong, the brilliant engineer who had invented FM radio technology, wrote to General Colton acknowledging and praising the importance and the courage of his decision to adopt FM for military use. Armstrong called it the most difficult decision of the history of radio, which anyone was ever called upon to make. He expressed his sincere hope that when the war was finally over, what Colton's organization and the engineers at companies like Motorola had accomplished in developing and fielding FM military radios could be properly laid before the world and given the acknowledgement and recognition it deserved. Armstrong had invented frequency modulation technology in 1933 after years of research and experimentation. He had donated free use of all his FM patents to the United States Army during World War II, waiving all royalty payments as his contribution to the war effort, and he had served in an advisory capacity to the Signal Corps on technical matters related to FM radio. However, Armstrong himself was not directly involved in the actual design and development of the SCR-300. That work was done by Noble's engineering team at Motorola, building on Armstrong's fundamental invention and applying it to the specific challenges of portable military radio. The decision to adopt FM for military radios had been genuinely controversial within both military and civilian radio engineering communities. It required the military to move away from familiar, proven AM technology that everyone understood and that had been the foundation of radio communications for decades. It required the military to embrace a newer, more complex system that many respected engineers and technical experts claimed was too sophisticated and too difficult to maintain for reliable military use under field conditions. It required substantial investment in new equipment designs, new manufacturing processes and tooling, new training programs for operators and maintenance personnel, and new logistic systems to support a completely different type of radio technology. But the combat results, the performance of the SCR-300 and other FM radios under actual battlefield conditions against real enemies, proved beyond any possible doubt that the decision to adopt FM had been absolutely correct. Despite the controversy and the difficulties, the SCR-300, along with the vehicular FM radios like the SCR-508 and SCR-608 that were developed in parallel, marked the beginning of a fundamental transition in military communications from AM to FM that would continue through the Korean War, through Vietnam, and into the modern era. Today's military radios, though incomparably more sophisticated with digital signal processing, frequency hopping, encryption, and satellite connectivity, still rely on many of the same fundamental FM principles that Daniel Noble and his team successfully implemented in the SCR-300 more than 8 decades ago. The improvement in communications range and reliability that the SCR-300 provided over the earlier SCR-536 walkie-talkie, from approximately 1 mile to 3 miles in typical operational use, with up to 5 miles achievable in optimal terrain and atmospheric conditions, represented far more than just a numerical increase in capability. It represented a fundamental and transformative change in how infantry units and combined arms forces could be commanded, controlled, and coordinated on the battlefield. Before the SCR-300 became available, company commanders had to stay relatively close to their battalion headquarters if they wanted to maintain reliable radio communications. This proximity requirement significantly limited tactical flexibility and often meant that commanders weren't positioned where they could best observe the enemy, understand the tactical situation, and effectively direct their units. With the SCR-300 providing reliable communications over 3 miles, and sometimes more, a company commander could operate several miles away from battalion headquarters and still maintain continuous radio contact. This extended range allowed for much more aggressive and flexible tactics, for wider envelopments around enemy flanks, for deeper penetrations into enemy territory, all executed with confidence that if reinforcements were urgently needed, if the tactical situation changed dramatically, if higher headquarters needed to issue new orders based on intelligence from other sectors, reliable communications will be maintained throughout. The psychological impact on soldiers of knowing they had reliable communications was also significant and shouldn't be underestimated. Knowing that they could call for help if needed, that artillery and air support were just a radio call away, that their higher headquarters knew where they were and what situation they were facing, all of this boosted morale and combat effectiveness in ways that were difficult to quantify, but very real. Soldiers who felt isolated, abandoned, and cut off from support fought less effectively and with lower morale than soldiers who knew they were connected to a larger organization that supported them and could come to their aid. The British military, which had pioneered much of military radio technology in the pre-war years and during the war, recognized the superior capabilities of the American SCR-300 and began development of their own version during the latter part of World War II. The wireless set number 31, which was similar in design and capability to the American BC-1000 component of the SCR-300 system, entered British military service in 1947 to 1948 after testing programs that had begun in 1947. This represented significant acknowledgement from a nation that had been at the forefront of military radio technology development that the American FM portable radio design represented the best approach to infantry communications. The adoption of the SCR-300 design concept by the British and subsequently by other Allied nations created important standardization benefits that extended well beyond World War II and became increasingly important as the Cold War developed and the North Atlantic Treaty Organization was formed. Allied forces could share maintenance expertise, training programs, and operational procedures. Communications between forces of different nations were simplified when they used compatible equipment. This interoperability proved valuable in combined operations and in the collective defense arrangements that characterized NATO. The technical and operational legacy of the SCR-300 extended far beyond World War II, continuing through the Korean War and into the Vietnam era. While the basic vacuum tube design of the SCR-300 was eventually superseded by lighter, more capable radios that used transistor technology instead of vacuum tubes, the fundamental concepts and design principles that had been pioneered in the SCR-300 remained standard in military portable radios for many decades. The IN/PRC-10, which replaced the SCR-300 in American service during the Korean War era, weighed approximately half as much while providing similar or slightly better communications performance. The highly successful PRC-25 and PRC-77 radio families that served throughout the Vietnam War and for decades afterward built directly on the same FM principles that the SCR-300 had proven in combat, but incorporated solid-state transistor technology that dramatically reduced size, weight, and power consumption while increasing reliability. The story of the SCR-300 is ultimately a story about technical courage, about innovation in the face of institutional resistance, and about the willingness to challenge conventional wisdom when you know there's a better way. When Daniel Noble told Major O'Connell in those meetings in Washington that the Army's plan to develop an AM portable radio was a grave mistake, when he forcefully insisted that FM was the right technology for portable military radio, despite the Army's clear preference for familiar AM technology, he was taking a very real professional and personal risk. He was contradicting the established preferences of the military procurement system. He was advocating for a more complex and potentially more expensive technological solution when the simpler, cheaper solution seemed adequate. He was asking busy military officers to trust his technical judgment over their own institutional preferences and their organization's established practices. But Noble understood something that many others did not fully grasp at the time. He understood that FM offered genuine fundamental advantages in battlefield communications that would more than justify its additional complexity and cost. He understood that soldiers operating in the electromagnetically hostile environment of modern mechanized warfare needed communications that would work reliably in the presence of massive electrical interference. He understood that clear voice transmission at the limits of range could mean the difference between successful coordination and catastrophic confusion. He was willing to stake his professional reputation on these beliefs, and his willingness to take that risk and fight for what he knew was right paid off in ways that saved countless lives and contributed to winning the war. The engineering team that turned Noble's vision and advocacy into working hardware, that solved the enormous technical challenges involved in creating a battery-powered FM portable radio that met all of the Army's demanding specifications, demonstrated the kind of focused, urgent, practical innovation that characterized American engineering and industrial mobilization at its finest during World War II. When Noble placed that specification sheet in front of Magnuski and Affronti and told them it was a life-and-death priority for the infantry, he wasn't using hyperbole or exaggerating for dramatic effect. He was stating a literal truth. Soldiers' lives depended on whether this radio worked reliably in combat. The engineering team understood the weight of that responsibility, and they delivered results that exceeded the Army's specifications and expectations. When Daniel Noble and Henry Magnuski stood 8 miles apart in those Kentucky fields in the spring of 1942, testing their prototype FM radio and achieving crystal-clear communications far beyond the Army's 3-mile requirement, they knew they had succeeded in creating something technically impressive and important. But neither of them could have fully understood or predicted the enormous scope and scale of that success, the impact their radio would have on the war and on subsequent military communications development. The SCR-300 would serve in every theater of World War II where American forces fought. It would be used on the volcanic islands of the Pacific, in the jungles of New Guinea and the Philippines, in the mountains of Italy, in the hedgerows of Normandy, in the forests of the Ardennes, in the final drive across Germany. It would be carried on the backs of infantry privates slogging through mud and jungle. It would be used by artillery-forward observers calling fire missions from exposed observation posts under enemy fire. It would be used by tank commanders coordinating combined arms operations. It would serve with airborne troopers jumping into enemy territory, with Marine raiders hitting hostile beaches, with Special Operations Forces operating behind enemy lines. The SCR-300 saved countless lives by enabling timely and accurate artillery fire that broke up enemy attacks before they could succeed. It saved lives by allowing isolated units to call for help and receive reinforcements in time. It saved lives by maintaining the command and control that prevented units from blundering into ambushes or friendly fire situations. It contributed to victory by giving American and Allied forces a decisive advantage in battlefield communications and coordination. After the war ended, the SCR-300 served as the foundation and proof of concept for generations of improved military radios that continued to use and refine the FM principles that Noble and his team had successfully proven in combat. Each successive generation of military portable radios built directly on the lessons learned from the SCR-300, incorporating new technologies like transistors and integrated circuits, but retaining the fundamental FM approach to battlefield communications. The improvement in battlefield communications capability that the SCR-300 represented was far more than just a technical achievement to be noted in engineering journals and military equipment catalogs. It was a war-winning advantage that gave American and Allied forces a decisive superiority in their ability to command, control, and coordinate forces on the battlefield. That communications superiority translated directly into tactical and operational advantages that helped defeat the Axis powers and win the war. That decisive advantage came from one engineer's clear technical vision and his courage in advocating for it against institutional resistance, from one brilliant engineering team's successful execution of an enormously challenging development program, and from one company's willingness to embrace innovation and take on difficult challenges even when the outcome was uncertain. The SCR-300 stands as an enduring testament to what technical insight, engineering excellence, and determined innovation can achieve when applied to problems where success literally means the difference between life and death, between victory and defeat. Today, more than 8 decades after those prototype tests in the Kentucky Spring, we still benefit from the legacy of Daniel Noble's revolutionary radio and from his unwavering determination to give American soldiers the very best communications technology that engineering skill and manufacturing capability could provide. The story of the SCR-300 reminds us that technical innovation, courage in challenging conventional wisdom, and excellence in execution can change the course of history.